Welcome to ClickMyProject.com. Our project title is Resource Shared Crypto Coprocessor of AES Encryption and Decryption with SHA-3. Our project main objective is omitting of computational intent is part of multiplication to improve the energy and operating speed of multiplier. So the AES algorithm using that the running time, performance and the overhead the energy are included. Our project abstract is this is CMOS technology research is a scaling threshold. So is the non-volatile memory NVMs. The approach was the becoming the hopefuls to the dynamic RAM. So dynamic RAM DRAM is because there's a low leakage of power and then improves scalability. So this is the first of all is the plain text encrypt the AES algorithms run time before the overhead of the encryption and then included. So this is the cost sensitive memories and then incentive logic operation capability of NVM non-volatile memory use the employ of proposed AESM technologies. This is a S box utilized along the AESIM methodology for the performance. So AESM technology is a calculator of both encryption and decryption measuring the minimum time and maximum times of the time per clock and time after clock deliveries. Averaging time record the operation of after clock, the latency of amount logic separately for the proposed AESIM encryption and decryption technology. This is the first of all is the our project flow explain. First of all is a plain text 128-bit. After that the using that key explanation of algorithm. So this algorithm were variable key pattern generation using that key explanations. So is a add round of AES algorithm and sub byte and then shift row operation and then mixed column operation and add route key. So this is XOR is yes showing to the inverse operation is a no and then go to the sub bytes. So the sub bytes shift row operations and then add round key and then ciphertext. Ciphertext is the encrypted of text. So this is the inverse of the concept of the decryption process. So this is the overall performance calculated in latency, throughput and minimum maximum after clock period. Our project we are using that the Vivada software for the Xilinx. So this is based on that upload that open the project. So this is open the project. So this is a simulation based on that behavioral and synthesis. So this is a behavioral checking syntax and then simulated behavioral model. So this is a first of all in code in Verilog VHDL. So this is based on a plain text and then this is a plain text and then key and then round of the AES algorithm wise. After that using that the plain text encryption and then decryption and then performance will be calculated and then Xbox will be used. So this is the overall of the code in this part. So so first we check the behavioral syntax. So this is the behavioral so this is completely successfully. After there is simulated of behavioral. So this is the waiting for the time and then completion for the finished. So this is a completion for the simulation. So this is a plain text, this is a key and then this count.